But anyway, cheers.
Cheers, and thank you for inviting me. I'm looking forward to this.
Yeah. Well, what would you like to tell everyone what exactly is combinatorics?
Yeah, it's a field of mathematics. It's a type of mathematics that's all about counting and patterns and related things. Pretty accessible. Most of the questions that you ask in combinatorics could be understood by kindergarten kids, but the answers tend to be elegant and hard. That's sort of the general flavor of it. So it could be a simple example could be, you've got the things on the table here, we can count them, but then we say, okay, if we want to put them in order, in some order, how many ways can you do that? Oh, but I want the phone to be before the Coke can. Oh, okay, that's some restriction.
Yeah.
So it gets harder to count it.
Yeah.
And then, but then when you go deeper into it, it becomes more and more sort of almost geometrical flavored. Sometimes algebraic if you want to go that way too, or other directions. But to me, there's a lot of sort of visualization and geometry in it, where it sometimes even becomes philosophical, like something like Ramsey Theory, which it starts off with the simplest of observations, like a pigeonhole principle. It's a little bit morbid. You've got 3 pigeons, for instance, and you're stuffing them into these holes. I don't know why you would want to do that. That seems cruel, but that's anyway. You've only got 2 of these boxes, and you've got 3 pigeons, so at least 2 of the pigeons have to share a box. So that's why it's called the pigeonhole principle. If you want to have a less morbid example, you got some kids, they're playing with toys. There aren't enough toys, so some of them have to share. So everyone can understand that. But if you use that thinking in more and more interesting and elegant ways, clever ways, then you can get some really deep mathematics that's some of the cutting edge maths today, some of the most trendy and hardest maths today, Ramsey Theory, by all the famous mathematicians, they like doing that sort of stuff. But at the heart of it is that no matter how random you try to get these things to be, some order will always appear. And there are some caveats. What does that actually mean? And is this true in general? And it's not quite. You have to have some sort of universe to put the chaos in, so to speak.
Okay.
But there's always emerge some order. Yeah. And then you got the opposite field, which is maybe closer to what you're doing, where you try to impose order, and yet you'll have a bit of disorder, a bit of randomness, chaos emerge, like with chaos theory or dynamical systems. So you got this nice dance of shadow and light, chaos and order that are intimately tied to each other, but seem to not completely get conquered by each other. So it's sort of like a shifting sands dance.
Yeah.
So as you can see, it sort of gets quite philosophical really quickly. Or you could just keep it at the basic level of how many things are on the table.
Yeah, there's one in your book about that, which is what was it? There were 3 people, and one was older than the other, and one wasn't. Which is sort of the entry level sort of thing.
Yeah. But that's actually a good example, because those sort of questions, at first you just say, what's going on? But the more you visualize and write down, and sort of you find more and more structure until, in the cases of those problems, there's just exactly one answer. Or usually at least, because the structure that's imposed forces you to go in this sort of little twisty-turny labyrinth until you get. So that's a really good example.
Yeah. So it's almost like asking the question creates this universe in which structure automatically appears. Is that something like that, or
a little bit? Yeah. Like sort of a classical example is like if you have 6 friends, or 6 people rather, and let's say that each of the people, pairwise, can be friends with each other or not. That's a bit simplistic, but in this simplistic little model. So you and I are friends, but I might not know that person there, and therefore not be friends with them. And then you can say, okay, so you got these 6 people, and you got all these lines between them, like lines between you and me, and they're either friend or not friend colored.
Okay.
And no matter how random your choice of those colored lines can be, you can always find at least one triangle of friends, 3 people who are all friends with each other, or all not friends with each other. And that's one of the tiny little examples of Ramsey theory. Okay. So you do have a structured universe, like we have, 6 people here and lines between them. But there are many ways of colouring those lines, so to speak. Yeah. Say, are we friends or not? Heaps. And you'd think that there'd be so much randomness there that would destroy any order, but surprisingly, a lot of order comes. Yeah. But what's from a mathematical perspective, as like when you get into it as an expert, you have another surprise, which is that you can definitely, with a bit of effort, show that order does emerge. But the types of results that you get in maths are, if you have a really, really big structure, then you might have a tiny little bit of order. So it really sort of not very impressive results. Yeah. But
sounds like the universe.
Yeah, exactly. And that's another good example too. Just like the universe, for unknown reasons, there's much more order than you'd expect. Yeah. So even if you have just a few people here and you're asking the same questions, maybe not with triangles, but maybe, like 4 people who are all connected by lines, then it turns out that there's way more order than we can explain with our present methods. Just like with the universe, you have these superstructures and we just don't know. Hopefully we will, but, right now.
That's fascinating. What is that? Is it like, are we saying that the number of permutations possible restricts pure randomness? Is it something like that, or is it more? It must be more complicated than that. But
yeah, that's partly it. Just the size of things, but also I think also the specific nature of the universe that we're defining. Okay. Like whether it's the physical universe or whether it's, here we have a bunch of people who can either be this or that, friends or not. And you can extend these things, generalize it a lot, but you'll always have some sort of structure in how you define the universe. Okay. And that together with its size forces some order. But the interesting thing is that there's way more order than you'd expect. Like, if we have 6 people and each of them can be friends or not, so, if you count how many lines there are between people, that's like, if you say, from me to, there are 5 lines from me to everyone else. And if you count in that sort of way, then there are going to be 15 lines all in all. And each of those lines you can either choose, are those 2 people connected by that line friend or not? So that's, 2 choices for each line. Yeah. If you want to 2 times 2 times 2, 15, 2 to the power of 15, which is, big number, 32,000 roughly. Yeah. That's a lot of ways of drawing those lines in that tiny little example. And yet we can always guarantee that there are 2 triangles of the same sort of friend or not friend color. Okay. So, and you can say more about that too. So it's not just that we can find order, but there's way more of it than we expect.
Okay. It's almost like you can't even eradicate it completely.
Exactly. Yeah. And the opposite, with, that if you try to make everything orderly, then something slips through the cracks.
Wow. So it's almost like a dial that you're shifting between complete order and complete chaos.
Yeah.
That's amazing.
We can get to the extremes and say everything is completely chaotic or everything is orderly, but then you get very, very boring situations like, there's nothing there, or, or there's just white noise, or, but yeah.
In combinatorics, is there a difference between, in all the fields you have studied, is there a difference between chaos and just our lack of ability to measure to enough accuracy?
Yeah, that's a really good question, and probably I reckon, because what we see as chaotic and random, if we knew more about it, then it would stop being chaotic and random. It would just be something that we know. Yeah. In fact, that gets to the heart of actually most of science, but also our psychology, because you can measure how random something is with, entropy, the notion of entropy, but you can measure in a specific way. And our brains are really good at that, because we've got to assess all the time, is this suddenly a good surprise or a bad surprise? We like to model the world and be secure in our modeling, so we expect the sun to rise. If it didn't, then it would be disturbing. And in that case, it would be greatly disturbing. So, and we're very good at measuring just how surprising something is. But that's another way of viewing randomness. Like if something is chaotic or random as we perceive it, that's that it's surprising. In other words, it's against our expectations. Okay. And expectations is based on what we know. Yes. So
it reflects the unknown and what we'd expect about the unknown.
Yes.
So it's not just I don't know it. It's that based on what I know, I'd expect the sun to rise tomorrow, even though I don't actually know that it will. Okay. And if it doesn't, then that's greatly surprising because it goes against what I know. I think these subtleties were. I didn't know this myself. I was just doing the maths, but the more I looked into it, all these subtleties were first looked at by philosophers like 200 years ago, especially Schopenhauer, and he was pretty advanced for his time, like basically saying what we now can figure out in mathematical terms, just saying, surprise, and in his case, he was talking about humor. That's the reaction to when something doesn't go according to our expectation. We have a reaction, and that could be. And psychologically, that makes sense. Like you get something that could be potentially scary or disturbing because it doesn't follow, our nice, safe expectations and rules and our modelling. But then that psychological mechanism turns it into something funny, so positive. Gives us some happy chemicals, and then we deal with it in a much more comfortable way or productive way. But it's funny now that we're so moved forward that we can talk about these psychological factors and philosophy for that matter, what is humor, what is beauty, all of that stuff via mathematical means, like measure the entropy. So again, it gets very philosophical very quickly, but I love the fact that in the last 10, 15 years now we have the tools, but also realize that we have the tools to deal with emotions, for instance, or philosophical concepts in a scientific way, which you used to just be philosophers debating and disagreeing for millennia and having fun with that, which I love too. But it's nice getting some actual answers by going out, measuring something, possibly putting electrodes on somebody and measuring what do you feel now, and then you can measure the brain scans and I could talk the rest of the interview about that sort of stuff too.
Oh, mate, go ahead. That's no worries at all.
I think there's a YouTube video that's of a talk that I did give about that, actually, if anyone's interested.
Oh, look, definitely. Once, before we forget, maybe later you can email me the links and I'll add them to the video.
Yeah, cool. Fascinating stuff. And I really like to do more research into that stuff because it's a wide open space where it's fascinating stuff, but also no one's looking at it because it's really you need a psychologist, a mathematician, possibly a computer scientist, and a philosopher in the same room, all working together, which never happens.
Well, hopefully now with the advent of cross-pollination, given what I call synthetic intelligence, people will be able to work
hive mind.
The hive mind. It's appearing. There were a couple of things you said that were so interesting to me. One of them was, I think implicitly what you're describing, it seems to me, is an objective metric system upon which all of us as observers agree. And so independent of our specific model of the world, we can adjust that model based upon the objective evidence. But that requires a belief that, because I can already hear some people I know saying, that's all hocus pocus, but which means that they reject the concept of that external metric in the first place.
Well, of course, we can never know for sure anything, and half the world believes that all of this is an illusion, and who am I to say that they're wrong? In fact, that seems quite plausible to me. But as, I used to, when I was young, believe something, then say, no, that's silly, and believe something else. Now I'm agnostic just because I know that I can't tell what real absolute truth is, if it indeed exists, which I'm beginning more to doubt. How can we be sure of that itself? But what we can do is, at a more functional level, say, okay, for instance, in the case of humor and beauty and stuff like that, I don't know whether, if I see the color red, that you see the same color red, that sort of philosophical discussion. But it doesn't really matter at a functional level. If we have a joke and we both laugh at it, then we share that experience, even if it's not the same exact experience. We can still. I think the technical term is qualia.
You mentioned that before.
So it doesn't matter if you're qualia of red is the same as mine, as long as we have commonality. And then you can also look a little bit more experimentally at that in a more objective way. So if you get a bunch of people and say, look at all these things, do you find them funny or beautiful or whatever? And then you can do some analysis of that. And there are two experiments that were interesting in that respect about a decade ago. One was with respect to humor, and they got a bunch of participants to look at nonsense words that were just fabricated, like jumbled up, and then they asked them, well, how funny on a scale from 0 to 10? I don't know.
How funny is this nonsense?
Yeah, exactly. Yeah. And then they also could measure the actual randomness of the word via the entropy function, and there was a strong correlation.
Wow!
So our brains are in real time assessing the randomness. So whether it's you that's doing it or me, this is objective. So whether you find it funny in your way or I find it funny in my way, whatever our experience of the funniness is, the degree of it can be measured.
Yeah,
it's a bit like similar to what's an electron. We can never say what it is, but we can measure it. The charge and the velocity and etc. So it's the what is not easy to answer. Sometimes we can't. What is humor? I don't know, but we can measure it. The same with beauty. And there was another experiment which pertains to mathematics. A beautiful experiment. They got these poor participants. No, probably not poor, but a bunch of them. And the reason I say poor is they put electrodes on their head and measured brain activity while they were given different things to experience, like some nice music or a face, evaluate whether it's pretty or not, the piece of music or the person's face, or and there was art, and I think also things to do with justice, like how just things are, but also maths itself. And then the question was, if people think that something's beautiful, how do they experience it? Well, of course, everyone's different, and there's a subjective experience. Except the brain centers were all lighting up the same place. Like the same brain centers were lighting up on everyone, regardless of who they were, and regardless of what sort of beauty they were observing, like whether it was maths beauty or a pretty face or whatever. So, and I think that's not super surprising if you think about it in retrospect, but so again it ties with the randomness, but it's also our brains are really good at seeing what order is. So if we have a mixture of seeing patterns and order, that's a really important function, a mathematical function that our brains are good at, and discerning degree of disorder or chaos or charm or those sort of breaking the symmetry type things. And if you have and both of those, when we detect each of those types of things, we get rewarded from our brain with happy chemicals. So if something's beautiful, it's a good it's a good combination of both, where you get a big level of happy chemicals, serotonin or dopamine or whatever. And then we say, this is beautiful. But, for the last 2,000 years, and, in a lot of different cultures, beauty was platonic. It was outside of ourselves. It was divine, or it was, a property that could be imbued, or, and that was also not only descriptive, but, something, when you create art, it has to be this way to imbue it with beauty. But now, if you think about it this way, from a perspective of just mathematical functions and measuring stuff, no, it's an emotion. It's a thought process. It's mathematical thought processes. Like we process something and see, there's a pattern, and we get rewarded for it. So it's an intrinsic thing, but in that talk, point out that it's also intrinsically mathematical. This emotion and the processes involved in it. So, the message to the philosophers there is that you are just looking at it all wrong, back to front. Like, it's not external. It's not like, it's psychological. And once you see it, wow, it's not only psychological, but measurably psychological. And again, the subjective experience can vary, but Well, the mechanisms are similar. There's, where in the brain is similar.
Yeah.
The degree of whatever is similar.
Yeah.
So we have all these functional similarities, even if we can never tell whether, the subjective. I mean, I would love to, this is a dream. I'm sure that many of you have the same dream that, some brain implant can let us feel each other's experiences. That would be so cool.
Yeah.
Or at least some, approximate mapping of that would be lovely. But until that happens, if ever, then we can only say, well, if it quacks like a duck, these two ducks quack similarly, or, these things quack similarly, so they might both be ducks, or,
Have you ever seen something that you saw, say, 10, 20 years ago, and given your change over time, have had a different subjective experience to that same thing?
A lot of the time. And I suppose, most of, well, maybe all of us have, like, if you go back to something from your childhood, and what? That's such a tiny little house or room or park or whatever. It was huge back then, And and it's sort of a little bit broken down and dingy. I thought it was really fancy back then, or whatever.
Because I saw this TV show recently on YouTube that was from 1995, and I was looking at it thinking it's so granular. But I've forgotten that at the time I didn't think that. It's only in comparison to what flat screens now, and it's changed my model of the world as such. And I just wonder, as you say, you get the implants and you see other people's worlds, whether or not it will actually force your model of the world to almost collapse because they see it so differently to yourself.
I mean, I'm sure you've had the same experiences also. If you look back at past things that you've achieved and were proud of at the time, well, sometimes you're still proud of them, but other times you're not.
That's every day. I find, like, for example, when I talk to my cousins who live in the Near East, there are things that I would take for granted, that we would take for granted, that are simple, even constructs of sentences.
I completely get what you're saying.
You just recently went overseas to see your family in Europe?
And my partner and her family are from Poland, so I've been learning very slowly, very badly Polish. But and to begin with, this is a crazy, stupid language. I don't like this at all, because there's some of the letters were a bit different and confusing to me, and also just the pronunciation does me in. It's so hard, but. After a while of looking at it, I said, no, actually, this is actually pretty cool. When you write something, that's what you say. And then the more I looked at it, and this seemed complicated, but no, that makes sense too. It's pretty logical. And once I got used to it, I was saying, that changed. But more importantly, then I started thinking about English. What the hell, English? What are you doing? Like, how does anyone learn English? That's crazy language. It makes no sense.
That's fascinating.
There are exceptions to the exceptions.
You've actually changed your inner experience even just by that transition. That's fascinating.
So if any of you are not English speakers, if you have learnt that as your second or third or whatever language, well done.
Yes, I think 47% of our audience is from India. And then I don't know if I told you, then Venezuela, Japan, Netherlands, Lebanon, and the US. They're the big ones.
So lots of, about half of you spoke something before English and had to learn this crazy language.
I remember as a kid learning long division and then not having to do it, obviously, when calculators came in. But what I did notice was that years later, 30, 40 years later, when I started studying abstract algebra, I realized that there was a direct analog between isomorphisms between two different polynomial rings and long division.
Exactly.
And I noticed that I was trying to teach a student. I said, this is like long division. And he looked at me, because he's only in his 20s. He looked at me and says, what's that? And I thought to myself, it doesn't matter that we don't need to learn long division, but the concept of long division allowed me to learn abstract algebra much more quickly. And my concern is now that with AI, that people don't need to physically calculate reduced row echelon forms or integrals, that they might lose what future analog can be derived from the actual concept of integrating.
I mean, that's always been a problem, the problem that I'm thinking about is that if people don't have just basic skills of arithmetic, then they lose a lot of their intuition for probabilities, for ratios, and similar things, or just everyday prices and whatnot. But that has serious impact on just being protected from misinformation.
Yes.
From advertising scams, from political scams. Like if a politician stands up and blatantly lies about so many percent, of immigrants do something bad, and you say, wait a second, that doesn't make sense. Just by a quick estimate there, or we increase we reduce the budget deficit by this much in 1 year. That's not actually technically possible, and you can quickly make those, or if someone is trying to, some telecompany, hey, you need a new phone, and and it's only this much, and I think it's not just the ability to do that, but also the confidence and just being able to have yourself in that gear all the time. I think a lot of people could grab the calculator and with a lot of effort. Actually, come to think of it, they can't actually. I'll give you an
example. That's gold. That's gold.
I mean, imagine it. Give pretty much any politician, just grab a random politician and ask them to do, add two fractions together. Just simple fractions. 1 out of 20 could do it on the spot. And if politicians can't do simple arithmetic, then the numbers that they're saying, they probably didn't understand them in the first place, which is a really scary thought. But it's also scary that then most of the population isn't trained to be protected against this waffle. And here's another scary thought. You and I are doing research, sort of at the cold face, so to speak, except nowadays, well, I don't know, the solar panel face?
The sun.
The sun face or wind face, I don't know. But no. So we go deep and we find some results after a whole lot of work. They might be small, but sometimes we strike gold and it's worth telling someone about. And then the university media department would then help us communicate it to a broader public. And that version might go into something like The Conversation, which is a journal for everyone, but it's sort of rather technical, a serious, unbiased type of journal. But then, of course, the other type of news media, Reuters or BBC or someone, Der Spiegel or someone serious like that, might want to take it up, and then it gets watered down and just a little bit. And that increases. Like the shorter the article, the less truth and subtlety you can place into it. And but imagine this: so if you're a busy minister, you have 1 minute to understand a complex subject. So you're going to be the person who's told the simplest, most incorrect, unsubtle version of it. By your helpers, your aides, assistants. So it starts with us having some sprawling thing that you really can't say. You might need an hour to explain it, and then it gets compacted until there's basically no truth left except a soundbite. But that's what our politicians half the time have to rely on, unless they actually read the reports, which they're probably too busy or otherwise to do. So,
wow,
that scares me sometimes. But
that's interesting, because when we say that we have a choice or right to choose, in terms of our democratic pathway, based on what information are we making these choices?
I mean, we do have a lot of data, and we have good ways of analysing. So probably a lot better than we used to. And of course, things are moving a lot faster, which goes against that as well. But the data is there. There are very, very good analysis. Like The Conversation I mentioned is one example of where academics try to tell the public, like, here, we're experts. We found the actual research and try to explain it. And then you've got think tanks who, they tend to be biased, of course, but, there are good think tanks that try to just say, here are the facts. And actually, increasingly, like you on YouTube, there are quite a lot of people on social media who do try to actually uncover facts and, act like good news agencies used to. And there are still some good media, but the traditional media doesn't play that role so much anymore, just because it's expensive to hire reporters, and news has to go a lot quicker than it used to. But also I think it's a bit paradoxical, because part of the reason for all of this misinformation, one of many reasons, is that is transparency. Because politicians were suddenly confronted with, the public wants to know, and fast, and so the closed doors were opened, but that only forces the politicians to respond quickly, but inaccurately, and they still got to they still have to have secrets, and but I think it's a lot harder to be a politician now, and an honest politician, and things just move so quickly, and so that transparency itself has made things less transparent in a upside down way.
There seems to be an evolutionary advantage to someone who can be more persuasive as opposed to being more truthful necessarily.
That's always been, and you've got populism that's gone up and down, but I think this wave of populism started about 20 years ago, in different places around the world at other points of time, but there is a big wave of it. And it's not going to end anytime soon, because a lot of the driving force is now populism via our social media and other algorithms that influence and earn a whole lot of money and drive a lot of our economy. On the other hand, then we've got pushback from just you, I, and anyone else living in this world who says, no, I'm not going to be manipulated by that. I met some students the other day say, no, I've just gone off social media and don't use AI.
Wow.
What? Completely? Yeah. Don't even have a smartphone. Wow. And that's extreme. But they said that it might be a tiny pocket of people, but they said it's a growing movement. And I don't think that that's going to be a dominant effect, but it's an example where you have a tiny little bit of pushback. And if you have other little tiny bits of pushback, for instance, with AI, it's the Wild West right now. And the more regulation that'll come and settle, then that's another type of pushback, and and things reach some sort of status quo until the next big change. So,
what's the point in knowing anything for new students when AI is now smart enough to cover them in first year to a large degree?
It depends really on what sort of stuff you're studying. If you're an art student, you might want to be able to act. You can't just say, "Yo, chat, how do I play this scene?" Can you play it for me? Maybe. If you're a doctor, you can't sort of, damn, I'm cutting someone's heart. Hey, yo, chat, can you help me? But if we talk about mathematics, then suddenly a lot of people will be asking, if we can get AI to do all the maths for us, then what's our role? And that's not actually a bad question, but still, someone's got to be designing the AI. You could get AI to do it, but someone's got to actually verify that it works and also use it appropriately. It's not, as we've seen the last couple of years, it's divine. It's so powerful, but at the same time, it still does remain a tool, just like UI would be, as we are tools in the sense of we have functions to do, but we're not infallible. We serve different purposes, but someone's still got to check our work and sometimes say, oh, sorry, that work, can you now look at this project instead? Or so there's got to be some sort of a governance. And maybe we'll get to the point where we have benevolent AI doing all that sort of stuff, but right now we're far from that. Massively rapid development of AI for sure, but we can't trust that it will have the capability to do the right thing, whatever that means. That's a whole, that's a whole question in itself. But also that, that it would want to do the right thing, or rather the makers of AI. So there's still a massive role for people to be in control and to verify and work with AI. And I'm thinking specifically in mathematics right now. If you don't understand what an AI is doing, sort of black box, then you just have to trust it. But, the answer might be wrong, or it might be referring to a question that's similar, but you just typed in the wrong thing, or because you didn't know what you're doing. It's a bit like calculators. They're great, they can do arithmetic that we can't. But if you don't know how to use a calculator, then then you're stuffed. So I think for a lot of people, some of the maths that is taught in schools, actually quite a lot, is just not worth it. Just like in the old days before calculators, you had slide rules. We don't need them anymore. And you could argue, a lot of similar things like calculus, algebra. Do we really need them in school? And I'd even go so far as to say, no, you don't need algebra. You don't need calculus unless you teach it properly. But to do that, you need the fundamentals. You first need to just play around with numbers, do arithmetic and some fractions, and that's about it. You don't actually need to do much more than that. But this is not being taught properly today. So if you don't have the basic intuition for numbers and ratios and stuff like that, then you can't do probability theory, you can't do statistics. You might be able to do calculus for sure, except it's not taught properly in schools, at least not here in Australia. The teachers might not be comfortable with it. The curriculum is very much rote learning instead of explore and find intuition and actually learn on your own terms and learn deeply so that it sticks. But also, why do you need it? Why do we have to learn this is actually a valid question. Whether it's calculus or algebra, I mean, these things are very, very important in a lot of fields, but they might not be important to most students. So cut it down, reduce the amount that you have to learn, but teach the stuff that you do learn properly. And then you can, once you have a grasp of, what is arithmetic, what are numbers, and what's geometry, what sort of visualization, a little bit of combinatorics. Well, I'm biased, but then go ahead and then use AI as your tools. But I think for a lot of people, this is not important. Hasn't been important. A place like Australia, which has lots and lots of natural resources, and a history of being against learning and research, also just in terms of how much money and status. Let's say research per GDP is really low. And if you're a top professor, your status is less than a real estate agent. It's different in other countries. But Australia is not geared for that sort of thing. So you could argue, well, we've got natural resources, who cares? But I think in the future, the jobs are all getting more and more abstract and generalist and mathematical. You look at the SEEK or Times Higher Education, the top 200 jobs listed. I think it used to be like 3 out of 10 used to be mathematicians of different types, like actuarial, maybe statistician and mathematician, and now it's about 8. And you need more and more mathematical thinking, regardless of what sector you're in. Whether you're a doctor or a lawyer or in IT or a teacher or whatever you need. You need more and more maths type thinking to have a decent job. And the jobs that are not decent, if you work in HR and doing pay stuff, well, AI can do that. There are still roles for us, but I think if you want to get ahead, you still need to understand the maths behind it. That was very long and scattered.
I've heard of companies now implementing AI as learning on the job via the actual current staff. And so they're sort of the next staff getting trained. Or maybe augmenting the few top staff and then they stop hiring new staff or something like that.
It's going to be interesting to see how it all falls out, because there have been big examples of, lots of examples of big companies getting rid of thousands of employees and saying, here, AI, and then AI didn't do quite as well as expected. Having to hire it back, and it's going a bit back and forward. Sometimes it makes sense, sometimes it doesn't. Actually, there was a study recently come up a month or two ago, which was very interesting in that respect. I believe them, but on average, there was a study that said, well, for IT workers, how much time does AI help you, or compared to when you weren't using AI? And on average, around about 20% time saved, which is great. But then the second part of the study was to look at the actual logs of how much time spent people were spending, and they're spending 20% more.
Oh, really?
I know.
What's that about?
So not only is AI, like, if you're an expert, use it properly, then it's a massive help. But for a lot of people, it's not only making you less productive, but also giving you the perception of, oh, this is a great idea, I'm saving time. My youngest kids are turning 5 soon, birthday party, so last year I I made said, yo, chat, can you design some birthday cards for invitation? And it did a pretty good job. A couple of iterations, and I chose one that was good, and then that took like 15 minutes. And then I spent 5 hours trying to get it right. I was tweaking the pixels. Oh no, there's a mistake there, and and I didn't realize that I was doing it. And it felt, oh wow, AI is so cool. And it would have been cool if I'd used it right. My partner did it this year, and she spent 15 minutes and
got it.
Yeah.
So we have to replace you with your partner.
So I actually did win.
Well done.
Thank you.
Yeah, I get this question from so many people when they talk about maths. They always say, they talk about addition or something. But I have my idea of what math is. But what is your idea to the layperson? What is maths?
Yeah. I think, if you're trying to solve a Rubik's Cube, or if you're playing Minecraft, or you're solving Sudoku puzzles, or playing Lego, all of that stuff is doing maths. Like, it's just trying to, you got some sort of system and some puzzles to solve. Maybe you're creating them yourself, in the case of Lego, or in case of you and me when we're doing research. Half the time we're creating our own puzzle to see whether something interesting might come out of it, and then just play around with it and try to be a bit clever, and then slowly get an understanding of the systems involved. And it involves a lot of analysis, a lot of slowly building up your intuition, and then getting creative with it, using the tools at hand. You and I might be scribbling, or using AI, for instance, or using mathematical software, or supercomputers to crunch numbers, or there might be a lot of different ways of approaching it. But I think that's pretty much, you can think of it in terms of solving little puzzles, or playing with Lego or Minecraft or whatever. And you don't see any of that in school or high school. You might see some in the early years, like the kindergarten and the first couple of years, where there's a lot of play involved. But once you get serious, in high school, you learn the formula, remember the formula, pass the test, get a good grade. There's no exploration, there's no play, there's no creativity.
To me, it's the reverse of maths.
Yeah, I know. It's exactly the opposite. It's like you're not really using your brain. You're just learning, formulas and cliches. It's like, learn how to write an essay. And that should be creative. Or learn how to draw a picture. That should be creative. But if you're told to draw a picture, you must do as follows. Here are the rules, and if you deviate, you get a bad mark. You're like. But unfortunately, almost nobody gets to the point where they can see the fun part of it. And to be honest, you do have to get a bit far before you, in a lot of areas, most possibly areas of maths, get to the fun bit. But there's a lot like recreational maths, like Sudoku or for instance Lego, Minecraft. That sort of thinking is really accessible to everyone. A lot of recreational maths problems, if you're thus inclined, are accessible and fun, and also it sets you in the same sort of spirit of mind as when you're doing research. When people think of mathematics, they probably think, as you say, of arithmetic, or they might think of, white men 200 years ago that were all geniuses and worked alone and were slightly weird. Russian hermits that say no to $1 million. That's just not what maths is. It's for everyone, for one thing. Regardless of where you are in the world, what culture, what gender, what age, we can all participate, we can all help. And that's another thing, you don't have to be a genius, and we might work alone here and there, but there's massive collaboration. You're collaborating with people, I'm collaborating with people.
I actually didn't realize how social it was.
Exactly, and a lot of emotion, and if I'm sure, when you're doing research, not even in the context of collaboration and everything, but it's a roller coaster of emotions. It's not just sort of robotic, or now I add two numbers together. It's not like that at all.
I used to love, for those, game nerds out there, I was in love with Zelda. So it was exploring with puzzles. And to me, my research, really. Wow. I find research is the most powerful version that you could ever get of Zelda in my head. Whereas you're researching this infinite landscape, and you get puzzles that you don't even know if you're going to solve, or if anyone can solve them or not. Like
Twilight Princess. This is great fun, as I expected it to be, but even more.
Yeah, I was actually, to be honest, I was actually a bit worried. I just had no idea how it would go.
We always get along, so I wasn't worried. But no, you're really good too. I go on And please feel free to edit and chop so that I don't go meandering on.
That's Dr. Angela I've met as well, very humble as well. Are there any of these that would interest you the most to talk about to anyone? This is your book that you've published.
Oh, the problems, these problems here?
Yeah.
Yeah. So the book itself was written by, well, David and I. As you say, David's a lovely colleague I've known now for quite a few years, actually. 15 years? Something. 20 years. But it was written in celebration of the 60th anniversary of the journal Parabola, which is this maths journal that our school has had since 1964. So, yeah, we wanted to celebrate that anniversary with this book, and also a new webpage for the website. But the book itself here was taking one of the main strengths of the journal, which is every issue since 1964 had some mathematical problems in them. So new and created them. And David actually has created so many himself. Like, he's been one of the problem editors for a couple of decades now, and he's probably the best person I know at creating really interesting, devious and elegant problems, like really lovely problems, unexpected. They sort of some of them look sort of boring or dry, and then you work on them and say, oh wow, that's cool. So by the time the 60 years are gone, around 1700 and something problems had then been published. And we thought, okay, my first idea was to have like a big coffee table book with all of the problems in them, but when I mentioned this to David and he got excited by the idea, he's got better judgment and a bit more wisdom than me too. He was saying, no, let's just go through them all and choose the best ones. So David being David and having high standards, we went through all of these problems and have selected about 450 of them, so about a quarter roughly. And then we, most of them were, in old print and everything, so we had to type them up and draw pictures and, LaTeX, and all very nice, and, debug. There were bugs here and there, and write, extra bits of solution. Then we ended up writing a whole new section about how to approach mathematical problems, and then there was other parts of the book too. It was really fun, a lot of work, but a really fun endeavor that sort of grew and grew. But the quality of the book was just really, really good. I mean, I'm a bit pedantic about quality. I've got high standards, but David, he's got even higher.
Wow.
And I mentioned the 450 for a reason, because he wanted us to first find these good ones, type them up, polish them up with beautiful pictures, everything, and then look at the 450 and take the best out of them.
Oh, wow.
After having done all this work, so intentionally discard maybe level. Maybe like half a year's worth just to throw in the bin, just to raise the quality. So we ended up with 330 or something problems. So around about a fifth or a sixth of the total selection of problems, which were good in the first place. So this was the best of the best, and with remastered and upgraded and extra material. So it's a lovely book, but that's the nature of it. So so all of the problems are worth looking at, depending on what you like. David loves the algebraic number theory stuff. I love the more combinatorial, the sort of geometric, visual stuff, and you or any of the viewers, you viewers might, but you can get all of these problems for free just by going to just Googling it, and a lot of it's just for free. But you can also go to the Parabola website, and all of the problems are there, and the issues with a lot of other content too.
I wanted to ask you actually at the beginning, can you give an example of how combinatorics either describes geometry or is related?
Yeah, there's a lot of overlap. Well, here's an example. If you place, if you just draw 5 dots, like on a table here, or whatever, then at least we can always find 4 of them, which will form a convex, a quadrilateral, a wonky rectangle, so to speak, but one that doesn't have a dent in it.
Okay.
So, And I think that was by Esther Klein, brilliant combinatorialist and mathematician, like about a century ago almost. She was friends with George Shekeresh and Paul Erdős. And they lived in Budapest at the time, and they were happily doing maths together, and a couple of other people. There was a lovely friendship crowd there. She proved this fact, or discovered and proved it, showed it to these two other guys, and they then extended it and published it, and now it's a famous theorem by them. But at the time, women didn't get credit for things like that. But it is now, I think it's called the Happy Ending Theory. Theorem.
Happy Ending Theorem.
During this collaboration, Esther and George fell in love, and they got married, and actually came to. They fled Hungary when it got invaded by the Soviet Union, and came to Australia. University of South Australia, I think it was. But then also, I think George was here for 40 years or something at UNSW.
Wow.
And he was one of the founders of Parabola, actually.
Oh, wow. Okay. Small world.
So clever, but so generous as well. Happy ending indeed.
Yeah. For everyone listening, I have a link to the book on the YouTube posts. Go down, you'll have a see. It's probably the third one down. If you have the money, I would definitely buy this book as a gift, especially for a bright young student. What do you think? I reckon, even people, young kids could slowly, maybe a bit too much for them, but maybe excellent high school students, you'd say? Or?
No, definitely. High school students and anyone else interested. I feel a bit sort of weird about spruiking my own book, but I have to say it is a beautiful book, whether you buy it or not. That's partly because this was a labour of love, but also partly because David is just so, he's got a real sense of aesthetics, standards, and it was a labour of love for him too.
That takes a level of scrutiny to go from 95% to 100%. It just takes
I haven't published a book before David had, and I published some, journal articles and research articles in a book chapter. But through that book chapter, I did get to know one of the editors for Taylor and Francis and CSE Press. And David had published a book before, beautiful book as expected, and with Taylor and Francis as well. So we're working together with these really good editors to begin with, and I think because David already had a good relationship with them, and I had a little bit, we were able to push through. No, we're going to do it properly. We're going to use LaTeX, and we're going to draw pictures, and the font's going to be like this, and we were very particular, and we must have been a pain in the neck, but they appreciated it in the end. In the end,
and they said, yes, let's work with them again. No,
Well, actually, but also at the end, where everything was just so beautifully polished, that. So they weren't comfortable with us having so much control, but in the end they appreciated that we used it for good. I think I stand my ground, and if I think that something should be a certain way, then if it's for a good cause, then I stand my ground, and I'm willing to push. But David, luckily he was so experienced and firm, and I might have got overrun if it had just been myself, and might. Been some mangled Word document that,
Is there anything else that comes to mind you wanted to talk about in particular, or?
How's your experience of now being a research mathematician?
Best thing in my life. It was the first time I found that I was on the right track in life.
That's so lovely to hear.
I just can't wait to get back and explore all the time. Nothing like undergrad. Undergrad was... goes. I loved it, but they're telling you what to do, and you're learning in the context of the fact that answers already exist. So the stakes aren't very high. But when you're researching, as you come up with the question first, and then think, is it a good question, and how do you answer it? And all this backwards, but
But I don't know how much you've talked about these things to your viewers, but I'm so happy to hear this, but also. School, high school, undergraduate studies, it's all very, very focused on you learn this and then you pass a test or, exam. So even if you understand it, it doesn't invite you to explore. And, half the time there is no answer. You're like, I don't know whether, well, maybe not for you, but for me, when I look at research questions, half the time I fail miserably.
Yeah.
Maths is hard, and a lot of times I can't answer the question, or the question was wrong in the first place, or whatever. So you have to embrace failure as part of mathematical research.
Yes.
And you're not at all trained to that. And actually, there is one thing that I feel is important to note for a lot of people that think about going into maths. Like a lot of the people who do enjoy maths in high school or even before, they do that because they might have been part of enrichment clubs or maths Olympia type things, and that there's a lot of value in that. I like those things, except that it again forces you into a wrong direction. It makes you very, very good at solving a problem to find an answer.
Yes.
But it doesn't necessarily invite you to take your time, slow down, explore, and fail, and find something new, or find out that the question didn't make sense. So, but it also is about winning and instead of collaborating or discovering. So the focus is wrong, and a lot of people who have gone that way crash and burn more than students who just run of the mill doubt themselves, but might end up actually better off. So, and I don't know how you did with all your undergraduate, but the way that you think and think deeply about things and are creative. I mean, I'm not at all surprised that you're doing so well and enjoying the research.
Thank you. You did predict that actually, which was it gave me a lot of courage, because in my undergrad, as you know, it just wasn't exactly the right fit. So it's a hit and miss. But in the research notes, look, I during Christmas I wrote this this paper. I spent 5 weeks. I wrote it, and it was a solution which I haven't published yet. It was a solution to a problem, and I was so proud because there's no solution that's been out for 200 years. Blah blah blah. I showed it to Dr. Chris, and he looked at it and goes, no.
That's the way it goes.
But because of him, I rewrote the whole paper in a whole new theorem, and then developed something which is now going to get published.
Exactly.
So, but as you say, I owe it to him and to the ability to say, you know what, you can develop something and it can be wrong, and that's okay. And that's the beautiful part of it.
Oh, it's awesome hearing you speak like that, because it is a mind shift to think, I have to win, to, oh, no, it's a long process, and you have to do hard work, you have to be creative, but also embrace the failures. And most of the failures can, have good stuff in them. You might have had a lot of good thoughts along the way that you can recycle that, or maybe understand something better, or pivot the question, or suddenly, oh wow, it failed because I hadn't seen the broader picture, and suddenly you see the broader picture, and so forth. So
that's the thing, and the failure was actually key to. In some ways, it's almost the cornerstone that allows you to leap into the paradigm shift, which comes after, as you say.
Good on you.
Well, Doc, they were good questions. Maybe you should be doing interviews asking. All right. Well, I might stop this now. So everyone, thank you so much if you've made it to the end, and we'll talk to you next time. As always, take life one smack at a time, and after hundreds of thousands of smack, you can interview someone. Ciao.
Thank you very much.
Oh, my pleasure, Doc.